Yeah.
Okay. Let's sit here.
Is it aligned correctly?
Sort of. Yeah, enough to say hi. Hi everybody, I'm Michael. Tonight I'm going to talk about the YouTube streamer. So the dream was that we spend about an hour each meeting, you know, setting up the YouTube stream and try different ways, and it always fails. Or sometimes it's been working with Danny taking over the stream, and through the notebook it's still a bit of a pain, isn't it?
Yeah. Yeah.
I wanted to get here and just hit a button and it go live, and then just copy and paste the link. That's the dream. It's still working, so that's good. I wanted to make it small, quick to set up, and no screen required. I don't need this apart from copying the link over, but I want to automate that process as well to email it to the list once I hit the button. So the setup's a 3B plus a Raspberry Pi. It's got a cheap microphone. It's only $20, but it seems to do the job. And the microphone's USB, which is important because on the Raspberry Pi the analog in is terrible. Don't bother using it. I used the latest Raspberry Pi Raspbian distro and just installed FFmpeg and screen, and then I scripted the rest. This is the case. It was just pieced together with my old Lego set that I had laying around. Yeah, it seemed very easy to put together, so I could fit everything, all the buttons, and Lego's great, still good. I wanted to be able to gracefully shut down and start the little Raspberry Pi with just a button on the side. To do that, I used a little shim. It's called an on-off shim from Peroni, from some manufacturer. It's called on-off shim, and you just solder the header on, you put it on top, and then you can install it just through one of these curl commands, but you can download the script and look at it first. I always recommend doing that. Don't just blindly run that command, actually have a look at it. And then it just installs some little scripts that listen to the button and then do a graceful shutdown. And also it means that you have to reroute the power. Instead of the power going into the main board, it goes into the shim directly.
Super question.
Yes.
On your previous picture,
Yes.
what part of that is the on-off button?
It's
Top left?
it's this tiny little button here.
Ah.
Yeah. So instead of the power going in there, it goes in there, and then you hit this little button to start it, and then if you want to shut it down, you hold this button for 6 seconds. And just when you finish holding it for 6 seconds, a green light will flash on the Raspberry Pi itself. It will start the shutdown process, and then it will completely cut the power after that.
Sorry, when you're saying the power's cut, is that cut by the shim?
Yes,
or-
cut by the
okay.
shim. So the shim's still powered,
Yep.
but the Raspberry Pi is completely cut of power.
Okay.
So it's good if you're running on a battery as well, and you want to just boot it up and shut it down and conserve power, because the shim hardly needs anything really. You know. They're relatively cheap. I think it was like $15 or something. You know, so it's worth it. Then I had another problem. I wanted to get the IP address of where I'm placing this, you know, so that in case I have to SSH to it or do a preview or something like that, I want to know the IP address of my YouTube streamer. It doesn't have a screen. It's just got 2 buttons and an LED. So I created a little script that flashes me the IP address and came up with these rules. So these rules are 3 flashes to tell me the script has started, then half a second between each flash to tell me the number, but then how do you show a 0? I just do a long flash for about a second or 2 seconds to show me a 0, and then how do you show a full stop? Well, that's 6 quick flashes. I don't know. You can come up with your own. That's the beauty of it, isn't it? But I've written down my keys, so that I know what hell it is. And then I tried it a few times to see if it made sense. Yeah, Morse code. Yeah, you could use Morse code, but anyway, that worked. Here's the interesting parts of my script. To get the IP address of the Wi-Fi, it's this beautiful long command. Basically, it uses the IP command and then does a bit of grep and awk and cutting to just get the raw IP address of the Wi-Fi once it's picked it up.
It looks like Python.
Yes, it's Python, so it's Python, yeah. And then it stores that into a little variable, and then another interesting part was how in the script I just set up the LED and button, pretty basic stuff if you've done Raspberry Pi GPIO hacking before, but it's just, yeah, you just tell it GPIO library where the button is and where the LED is, and then you can interact with it. You tell it that the LED is out and the button's in, and then I just go through that IP string and I pull it apart and send it through a for loop, and then I do my flashes, depending if it's a 1, a 0, whatever it is, you know, until it's finished. And I tested it out a few times, and it's without knowing the IP address. When I tested it out at this pub, I picked the wrong day, not knowing how popular football is at this pub, but I couldn't actually get in the pub, so I just sat out the front. But it worked. It worked. I could actually get to the IP address and SSH in with my mobile phone to my Pi, and then I just drove off. But I was, you know, wanted to test it at the site.
Does it do it like every 5 minutes or something? Like if you miss the first one or the first part of the sequence.
Oh,
how
right.
do you-
It's on a button, so you can hit it again.
Oh,
Yeah, that's another reason why I put it on a button instead of in a startup script.
Yeah.
Because I found if I put it in the startup script, sometimes it took a long time for the Wi-Fi to connect to a router. You don't know how long that is. And sometimes, as you said, you would miss it a lot of the time. And, you know, so I've actually slowed down all the sleeps and everything, made it a little bit longer, but at least I don't miss the IP address. But if I do, I can hit the button again. So the button that's harder to get to, sort of jammed up right next to the LED, that's the one for the IP address, and the easier access one is the start the stream. They're not labelled, but I know which one they are. That's just 6 rapid blinks. There's just 0.1 of a second in between them, and it just blinks 6 times, and then it waits 2 seconds between a dot. And I'm going to include the full script with this presentation, so you can look at it and pick it apart. Then the Wi-Fi setup. So, of course, I had to put the Wi-Fi settings for this pub in the machine before I came here, with the 2 spaces in it, you know, the all-important 2 spaces. And but I also wanted a fallback plan in case that didn't work, so I also put my mobile phone Wi-Fi tether in there as well, just to, that's something I could test at home, which is important. But then I've got 2 that may be on at the same time, so I used a priority in the configuration. In the WPA supplicant conf, you can use a priority. The higher the priority, so the higher the number, it picks that one first. Not priority 1 is not the one that's going to pick. So if you've got priority 2, it's going to pick that one before priority 1. So the higher the number. It's not the way you think it would work, really. I did it wrong a few times, and I'm going, why is it picking my phone and not the pub? But so I've put the pub as well, I've actually put the pub as 2. In this, I've stuffed it up, and I put my phone as number 1.
The
Okay.
higher the priority,
Hi, the number. Oh yeah.
Yeah, it's round the wrong way there.
Right, yeah, the number.
The other question I had was, as a fallback, you may want to consider having that spin up as its own base station with no authentication.
Oh yeah,
Because a lot of kit these days, when you get it and it's not configured, like the
as an
Chrome-
access point.
the Chromecast, for instance,
Yeah.
it'll spin up its own access network.
But then you have to use host APD.
Well,
Which
whatever,
is an-
but the point
yeah.
is that you can set that up.
That would be good.
Default creds.
Yep.
And SSH in, set whatever you need to set using your thing, or even a web GUI if you've got one.
Yeah, I could
Oh,
put
that's
together
it.
web GUI.
Yeah, so it comes up in default,
Yeah.
which gives you access over the wireless, and then you play with it,
and
and
then
just
put
let
it
it
in.
go.
That would be a good idea. Then I wouldn't have to pre-set it up for a venue. So the microphone was the next area that I worked on. And first off, when you start a stream for YouTube, it requires an audio track. You must have one. I'll go over how I faked one in FFmpeg later when I didn't have a microphone. But when I purchased my microphone, I wanted to test that it worked, so I used a record and I outputted to a .wav file, and then yeah, you can turn it up using Alsa Mixer and all that, and you can play it back using MPlayer, and that seemed to work. It's quite good. Then I tested it with FFmpeg, and things got a little bit trickier, but you have to tell it exactly which hardware it's plugged into, and there might be multiple. On the Raspberry Pi, there's the very first one, which is 0, is the headphone jack, which is also microphone in, pretty sure. And then your USB is hardware 1. So you've got to tell that with the plug HW:1. And then the -T in this command here just grabs 30 seconds, so it's -T30.
I'm sorry, every time you see plug HW there, I was reading it as blue W, and I couldn't work out what the hell you're talking about.
Yeah, the plug hardware.
Blue.
Plug hardware. Okay. Yeah. So then I had all this on a little breadboard at the start, you know, and it's not a complicated circuit, but I don't do a lot of circuits, so I wanted to sort of put the circuit outside the case, so I could one day attach it nicely. At the moment it's just dangling out the side there, but I didn't want it directly on the GPIO because it's a little bit tricky to get your hand in there and hit the button. So it's on 2 little boards. Here's the circuit design. Yeah, you probably say that's crap, but you could have done that better in a nice package or used proper things. But I just used a pencil and a bit of paper and yeah, put it together like that. And this is what it looks like when it's finished. Those sitting closer can see the real thing, but it's just 2 buttons, and then the LED requires a 100 ohm, that's a 92 ohm resistor, but yeah, it just takes off some of the pressure off the GPIO. Yep, that's still going good. Onto FFmpeg, which does the main grunt of the processing. Okay, so this is a very long command. It's beautiful. This is when I was faking the audio stream, but I was still grabbing the video stream from Raspberry Vid, which is the built-in way of capturing the video content from a Raspberry Pi camera. I'll go through some of the options. I'll break this down, but pretty much in this particular long command, the A codec has the ability to tell it a lot of settings about your fake audio track, so that you can satisfy YouTube and it'll actually play. And another important thing is to use FLV for streaming to YouTube from FFmpeg. You can use others, but this is the easiest way to get get it accepted, and it also means it's not too much overhead for the little CPU in the Raspberry Pi. So right at the end is quite interesting, and you have to put in your YouTube link where you're going to stream it to. You can set up, you know, your live account pretty easy, and you get a special key, which of course is not in my slides because that's particular to your account. So you put that somewhere. I tuck it away in an environment file, but you can put it outside the script and just include it like that with $sign key. That's just a variable. So this is streaming with the microphone, so you'll see that I've got the -I plug HW1 in there on the second line, and that's that's where it interacts with the USB mic. So I'll break that down that great big command now. So this is a Raspberry bit switches. The -O hyphen is just going to output the stream to the pipe, so I can use it in the next command. The -T0 means record forever until I gracefully kill the thing. And FPS is the frames per second, 25 I set it to. -B is the bit rate, where I played around with multiple settings, and I found that 750 kilobits per second was good for what we require, hopefully.
Is that depending on the bandwidth available to you?
Yes, yeah. So I did a whole heap of tests, and for the pub, that's the best I could push out. Obviously, if you had a better internet, you would try to push a little bit more. But and it depends on what you're trying to capture. You're trying to capture pretty big slides here, and just a person's talking. So, but if you've got really fine detail, then you'll want to bump that up quite a lot. Yeah. Audio FFmpeg. I found that this use wall clock timestamps to 1. It syncs the video with the audio a bit better, but it's still a little bit off at the moment. It's something I've got to work on.
Our viewer says that there's a system click as well along with it.
It's beautiful. That's good. That's good. Then you have to put the audio format as ELSA. Set the audio to AAC format. That's pretty important, and 128 kilobit. And you have to use a strict experimental, otherwise you can't use AAC in my version of FFmpeg. That might be different in later versions of FFmpeg, but then I have to use it. Video switches, I have to use H.264 because that's what the Raspberry vid's giving me, so I want to keep it the same, and then I'm copying the video format over. And I'm putting a keyframe every 50. I forgot why that's important, but it said I needed it, so put it in there. And then, yes, this is the output switches where I use FLV.
FLV is flash video.
Flash video, that's right, yeah, and YouTube loves that. So, and then the actual stream link with a special key. That's about it for the whole great big command. And then, this is my research of the quality settings for that -B bitrate. So I went through, that should be bits I suppose, but and then how much megabits per second it was uploading, and if it worked, and the quality. So we're sort of sitting at medium quality here, but that's all the pub can handle, so you know. Scripting, store the keys in /etc/environment, but there's probably an even better way of doing that, but that's pretty protected. You have to be root to look at it, I think. And I just used bash for the stream command, and I used Python to control the button and the LED. I also built like a little preview mode so that I could angle this camera because there's quite a delay between the stream on the screen. It's a bit annoying to actually set up, so I created a stream_VLC little bash script that outputs it, and you can just play it on your notebook and then make sure that it's got the right angle.
Can I suggest for working out what the audio delay in respect to the video, you might wish to have essentially a clapperboard.
Okay.
And then do some analysis based on that as to whether you need to adjust your audio forward. Like, I know that I'm more familiar with MNcoder,
Yep.
but it allows you to adjust the timing delay between the video and the audio.
Okay.
I'm assuming that FFmpeg probably does as well, and that might help fixing up that particular issue.
Okay, I'll have a look at the clapperboard. Yeah.
Or
With that.
whatever.
Yep.
Video.
So I put these two scripts, IP blink and the button Python files into my etc rc.local just at the end. They just run for loops over and over again, so it's not the best way to do things, but it works. They just sit there waiting for me to hit the button. And so what's next? Well, really, I want to get picture-in-picture going with Danny's device that captures the notebook screen off the HDMI and somehow puts that into the USB, and then put the person that's doing the talk into a picture-in-picture, and that can be done with FFmpeg. I want a 3D printer case for it, although the Lego looks pretty cool. And I want it to auto-post the YouTube link, because every time you start the stream, it generates a new, unique link for that session. I want it to automatically post that to the email and IRC, so that saves me a bit more time. This is just about automating everything so we can get into the talks a bit faster and enjoy more beer. So these are my references. There's a few little tutorials I followed. Okay. Any questions?
Is that the default Raspberry Pi camera?
Yes, that is just standard version 2, not the IR version. Yeah, just a standard camera. Yeah, you can pick up for $25.
Yep.
Yeah. So it does 1080. Yeah, high def.
It's pretty, the potential exists to package it up, plug it into your power bank, hook it up to your mobile phone, and basically be mobile live feed at whatever you want it to do. That's really, I like that as a concept, and obviously, I don't know if they've got any devices that do that stuff, but
A phone.
Phone does. A phone, but for
hadn't thought of that.
yeah, I mean you can do these things with a phone, but then where I want to take it with a picture-in-picture and grabbing that sort of information and auto-posting, then it becomes impossible to do on a phone. So yeah, I had to start off with this platform.
That streaming security video thing that you were able to repurpose
Yes.
old handsets.
Yes. What sorry, what about?
Well, I mean,
yeah.
that's, I guess, another option in the sense that you've already got a stream from there, but then I guess you've got to have something in the middle to do the mixing, I suppose. So.
Yeah, you still have to mix everything. So it's doing the stream at the moment. Now I can just add to it. Yeah. Yeah.
So was there a lag between audio and video when you tested on another network or on this one?
It seemed much closer in sync when I was testing it at home, but I've got like a 100 by 40 internet. I think this is like a 1 up, 20 down or something.
Like, what was the sampling rate for audio and video? Like, is there any, like, are they in sync? Like, are you sampling the video, like if I want to stream a video of given quality, I have to sample audio at this rate, video at this rate.
Okay, well I'm not sure if I'm matching the rates, because the audio is at 128 kilobit and the video is completely different.
This could be
but-
like the lagging issue could be like for many reasons, but now it seems like mostly due to network or sampling issue or the latency in your like all the stuff, software stuff you need. So
Because the video and the
see-
audio get packetized at different times, you're really going to struggle to ever get them to perfectly align with each other. The best way to do it is to try and get the timestamps to work out the same.
That's-
so that it
that's
gets
why-
reconstructed at the other end in the right. So the player at the other end can then do a little bit of buffering. Like the VLC will do a lot of buffering with timestamps to try and correct.
And this could also be like you're streaming using RTSP real time streaming protocol, or so if you stream using like HTTP streaming,
Yeah.
HTTP live streaming, then it's like they can synchronize with the start of the video.
Oh, okay.
Not related to the, so that could be like
So instead of using RTSP, what do I use instead?
HTTP live streaming.
STP.
But
live stream.
HTTP, but this
HTTP,
device
sorry.
doesn't have like web browser, so
It's got a web browser, but yeah, I mean it's just
then you can easily like stream it. All you need to do is like record to, like you can do it two way.
Mhm.
One is like you can stream the pre-recorded video.
Mhm.
Second is like you can stream live. So most of the streaming nowadays is like HTTP live streaming.
Mhm.
So rather than using RTSP, like separate connections, like RTSP, they use separate connections for audio, video, and then they like all those syncing stuff. But HTTP is like they deliver packets using normal HTTP packets.
yeah.
So the benefits are like it's accessible to all the different devices because it's HTTP port 80 is not blocked by firewalls and routers. And the second issue is like lag.
Mm.
So the biggest reason HTTP live streaming is invented is for like lagging stuff, because previously they were using a real-time streaming protocol. So Netflix, YouTube, Google, they all use like HTTP live stream.
Okay. Yeah, I'll check
So
that out.
So if
Yep.
this have like so if this device has a web browser kind of stuff,
Mm.
you can easily stream it using HTTP.
Okay. I'll check that out too. Yeah. Cool. Thanks everybody. Okay.
The
Yep.
little OLED screens you can get for
Yeah.
a couple of bucks.
Okay.
Programming those
Yes.
off your GPIO is trivial next step from what you've done with your turning your LED on and off.
Right.
To actually send commands to them
Yeah.
is only another couple of commands. It's really simple.
Oh, okay.
You're almost there. So
Right.
if you were to add a few more commands, you could write to the OLED.
That would
have one of
save
those
me-
cheap little OLEDs.
yeah.
They're only about this big, so they'll fit nicely on top of the box.
Right. That would
And
be
that'll
good.
give you your IP address and any other data you want to put on it.
Cool.
Before we get fancy, can we see the ghetto solution in action? The flashing light?
Oh yeah. Okay.
Yeah, you're absolutely